Okay, so when talking about circles, theta in all of our formulas has to be in radians. Now, normally they will give it to you in radians, but let's say they give you an angle in the circle in terms of degrees, you have to know how to convert. So think of them as a ratio in terms of the whole unit circle. So if they give you an angle in degrees, the whole circle would be equal to 360 degrees. So you can make that a ratio in terms of whatever the corresponding radian angle would be over 2 pi, which is the whole circle. And then you cross multiply and solve. So it's pretty straightforward. Just keep in mind that concept if they ever give it to you in degrees, which I hope that they won't. So this first formula you have here is the length of an arc. That is on your formula sheet. So length L would be the length of the arc, and R would be the radius, and theta would be the measurement of the angle in terms of radians. So the length of an arc is what I call the crust of the pizza. So when you look at this picture here, the curved route from A to B is the arc. So that's your arc from A to B. Okay, the next thing on your notes talks about minor versus major arc. So a minor arc is the smaller arc, where the major arc is the larger arc, which is, again, pretty straightforward. Now, let's say you're trying to find the major arc. This formula here, again, this one is not on your formula sheet, but it should be pretty straightforward. You can think of it as you're taking, if I have a circle and I have this pizza slice and they want me to find the major arc. Now the major arc is this red crust. So we find that red arc by doing the blue circle, the circumference, so 2 pi r, minus the small arc, which we know that formula to be r theta, which is, see how these both have r in them? So they just factored it out, and that's how they get this formula. It's the same thing, just a different way of writing it. But I think it's pretty, as long as you conceptualize the idea of how the major and minor arc come together to make the whole circumference, you don't need to memorize that formula. You just need to be able to think it through. But if you know yourself and you say that would confuse me to death, then you need to memorize this formula because they do not give it to you on the test. The next formula is the area of a sector, and that is on your formula sheet. So the area of the sector is the whole pizza slice. So this is our area of the sector. This whole thing would be shaded in. So that's the area of a sector formula. Okay. The next one is the length of a chord. So a chord is the straight line from A to B. This formula is not on your formula sheet. This is a faster formula, but if you know your brain space and you think I can't memorize another formula, then keep in mind that this just makes a triangle. So if I look at this shape here without the purple shaded region, then it's just a triangle. And we know how to find the length of that because you can use cosine rule. So we could also use cosine rule. So here we would have the chord is equal to r squared plus r squared minus 2 times r times the cosine of the angle, which when you multiply it out, we get 2r squared minus 2r squared cosine theta. So you can still solve for that piece. But some of you, just since we just talked about it, I'm going to keep simplifying this. This concept is where we get the double angle formula from. If you can imagine, you would have 1 minus cosine theta there. So, I mean, anyway, you don't need to know that. But You do have a way of finding the length of a chord without that formula, which is why I assume they didn't put it on the formula sheet. But in terms of typing it into your calculator and how quickly you can move, this formula here is a convenient one to know and have memorized if you think you can. But again, it's not one you have to memorize because there is another way to approach it using cosine rule. Okay, the next thing is the perimeter of the minor segment. So when I talk about this minor segment here, it's just that shaded purple region. And so the perimeter would be the arc plus the length of the chord. Not on your formula sheet. I don't think they'll ask for it very often, but again, I think it's pretty straightforward. And then the area of that shaded segment, they give us this formula here. So we know the area of the whole piece. If you were to distribute that 1/2 r squared, we have 1/2 r squared theta. So that is the whole pizza. And then you have minus 1/2 r squared sine theta. So 1/2 r squared sine theta, if you remember from the last section we did, is the area of a triangle. So that's here, just this triangle. So if we do green minus blue, that's what gives us purple. So that's where this formula comes from. So again, not a formula on the formula sheet. It's something you can work through, but if you have it memorized, it's not the worst thing in the world. Okay, so those are the notes for circles and concepts of circles. So you can go ahead and move on to this additional homework. I posted Delta Math, but these are IB styled questions. So IB does ask you to find the length of a chord. Again, they do not give you this length of a chord formula on the formula sheet, but you do know how to find it. So depending on which way you want to do it, just keep in mind that this formula, if you're going to practice it, is not on your formula sheet. So decide which way works best for you, either using cosine rule or that formula. But remember, if you choose to use that formula, you have to memorize it. They also ask for the perimeters of the minor segments and the area of the minor segments. So again, the minor segment here is on any of these is where you go from A to B on the curled, A to B on the straight, and shaded in. So those are the minor segments. Okay, so that is it for now for these notes. Good luck.